Hey guys, today we're going to look at a gizmo that's basically going to run us through the water cycle. It's kind of, I don't know, it's not the most robust piece of information here or activity, but I want to run you through it just because it kind of is going to give you information that you need. So if you're following along with, I'm going to let you run at your own pace and just kind of show you what we're trying to do. But basically, if you were to follow along with your Google Doc, which looks like this guy here, basically it's going to run you through clicking through a bunch of the storage areas in the water cycle. And then afterwards, you kind of can break it down into processes and transitions that occur in the water cycle. So usually the water cycle is broken down into storage areas and processes to get to those storage areas. So if you follow through this, you're not really like running this crazy simulation. It's just taking you to different areas that kind of give you information about those areas. And if you were here, we would be doing something similar to this. Usually we get some dice and go out in the hall, and I have all of the storage areas just pasted up along the walls, and you roll dice and move within those storage areas, and you keep track of where you've moved. And then afterwards we come in and we talk about the transitions to get from one place to another. So I might beef up some of this transition part because it's kind of, well, I might leave it the way it is just for the sake of speed. So let's get to it. Basically what you're going to do is follow along with that Google Doc, but it's going to basically tell you to click on, I think it starts at aquifer, and then it asks you questions. Just fill out that sheet. An aquifer is an underground layer of porous rock, blah, blah, blah. It's basically groundwater. So if you ever hear me refer to something as groundwater, that's water that's penetrated deep into the ground, and usually it's trapped in rock, and that's an aquifer. It's basically a natural filter, so a lot of the water that comes up out of aquifers is really clean and pure. One of the biggest aquifers around here is called the Edwards Aquifer, which is out in underneath Austin, basically. If you drink Ozarka water, it used to come from the Edwards Aquifer. But anyway, its recharge zones are actually a little bit further up in our area. So in a recharge zone is basically when it rains here, by the time the water seeps into that rock, it's in the Edwards Aquifer that's out closer to Austin. Anyway, so you're going to click on what it tells you to click on, and then answer the questions that are there. After aquifer, I think it takes you to maybe well. A well usually is a hole that we dig that gets into an aquifer, and then we can pull water from that, and we can use it for whatever purposes we want. I used to live on land that had a well. Our well was at 1,500 feet, and so we were pulling water that actually recharges from a zone out near Decatur. So that means if it rains in Decatur, that recharges our well. Wells can run dry, and the way that they run dry is if you have numerous wells pulling from the same aquifer. That aquifer is like an underground lake, and it can actually go down as you're pulling water from it. And if your well is sticking in that groundwater, as the groundwater goes down, if it gets below your well, then your well won't pull water anymore. So that's basically how wells work. Anyway, then next, I can't remember if it goes to agriculture or person, but if you follow your sheet, it'll take you to those places, bring you around a bunch of different places, and then come back full circle so that we complete the cycle. Sorry about that. So you complete the cycle. So again, follow your sheet. Let me pull that up real quick. So follow your sheet. It'll take you through the entire cycle. So notice we started at aquifer, we ended aquifer, and then the second part takes you through the transition phases, and kind of explains those. Most of those go back to phase changes, and then so work through that. And then the last question kind of talks about human implications of water scarcity, which is really kind of, when I talk about the water cycle, I also like to talk about that. So let me kind of show you that. As you go through, it's going to ask you what percentage of water is in different areas. Notice that if we took all of the water on Earth, 97% of it is ocean water, right? Only 3% of the water on Earth is fresh water that we could actually use as drinkable water without having to remove the salt. Removing salt requires a lot of energy, so it's not necessarily the best thing to do. So then if we look at the fresh water, so of the 3% fresh water that we have, notice that 68.7% of it is trapped in ice caps and glaciers. 30% of it is actually trapped underground in those aquifers. So notice that almost 100% of it is in places that it's hard to get, right? And then surface water like lakes and rivers and all that stuff comprises only 0.9% of that 3%, right? So very little amount of water on Earth is available for us to just grab and use. And then if we look at just that surface water, notice that we got lakes, rivers, and swamps. So lakes are 87% of that 0.3%. So that is a really, really, really small number that is in lakes. 2% is in rivers, which kind of makes sense because rivers run across the land. Lakes are storage areas, so lakes are much bigger and catch all that water that comes from rivers. So that kind of makes some sense. And then swamps, which is kind of a hard place to get water from that we want to use, is going to be 11%. So notice that 87% of 3% of the entire amount of water on Earth is right there ready for us to easily use, which is not a lot. So that's pretty important, especially when you get to that last question on the Google deal. But some of these numbers might be slightly different than what you see in the gizmo. It's okay. They're all probably pretty close. You will kind of have some of this crop up on quizzes. I'm not going to ask you specifically, hey, how much water is trapped in groundwater? But I want you to have that general idea that most of the water on Earth is ocean water. Sorry, and then that small 3% is fresh water, and of that, most of it is trapped in ice caps and glaciers, right? So, I'm sorry, I think I said lakes were 87% of 3% earlier, but no, lakes are 87% of 0.3%, so it's even less than what I was saying when I messed up earlier. So just know all that, that basically you got this huge chunk, most of it isn't even usable, and then of that part that is usable, most of that isn't usable, and then that kind of leads you to understand why there is such a problem with water shortages across the globe. So look at that, look at the gizmo. There will be a quiz as well on this, so that should get you where you need to be for Unit 4, and a test will probably follow soon. Until then, get her done, and we will talk to you later.